Hello everyone, we want to do some word problems in trigonometry using sine law. So we have a word problem here. There are two ships that are located 15 kilometers apart. This is in the middle of the ocean. And the first ship is called Alpha and the other one is called Beta. These are the names of these ships. And Alpha's angle to the entrance of the port is 55 degrees. This point C here is the entrance to the port, and the angle that this ship makes with the entrance is like 55 degrees with respect to beta, and beta's angle, the other ship's angle to the entrance to the port, is 45 degrees with respect to the other ship alpha. So the angles are given. Now, the first question here is which ship is closer to the port entrance? Like, is it like this distance BC that is smaller, or is it AC that is smaller? And this is sort of common sense kind of question. The shortest side is always opposite to the smallest angle. So if this is 45 degrees, the side opposite that would be smaller than the other side because the other side is opposite to a larger angle. So this angle is 45, the other one is 55. The side opposite the smaller angle is shorter. So that's a sort of common sense kind of question. And we want to find out how far is this sheep from the port. So the distance is what we need to find. The distance between the ship that is closer to the port. So here we have a diagram that shows the story of the problem, and often in the textbook there are also diagrams, images given that they describe the story of the problem. But then we draw a geometric labeled diagram, like I did here. We put the letters, we put the measurements, everything, and we label everything. And then we start working with this geometric diagram, which is easier. So basically, we said that side B is smaller than side A. So B is smaller than A. It's shorter than A. And we're trying to find the distance between the ship that is closer to the entrance to the port. That is B. We want to find what B equals. So when you look at this exercise, you see that two angles and one contained side are given. So this points at the use of sine law. So we're going to say, first of all, we're going to say angle C equals 180, take away 55, take away 45. So that's 100. So the difference would be 80 degrees, first of all. So now that we know angle C is 80 degrees, so we say C over sine C equals E over sine B. Okay? I could have written A over sine A, but that's when I want to find side A. But here we want to find side B clearly. So I'm going to say B equals C times sine of B over sine of C by using cross multiplication. So C is 15 kilometers. Angle B was 45 degrees. So 15 times sine of 45 divided by sine of 80 degrees, right? So we did the substitution, and now we need to use a calculator to find out the answer, which would be 10.8. Hopefully you got the same answer on your calculator, 10.8 kilometers, okay? So this is the distance between the ship that is closer to the entrance to the port. So it's just one of many application questions that we can do using sine law. Okay, what you need to do, you have to practice and try to do as many questions as you can, and try to apply this famous law known as sine law. Area of a triangle, if I ask anybody what the area of a triangle is, everybody knows base times side divided by 2. That comes from grade 1, grade 2. So we have a triangle. The base is BC, the height or the altitude is AH, and the area is base times height divided by 2 clearly. So area is 1/2 times side BC times AH. Instead of side BC, we can of course write lowercase a. It's the same thing. But AH is the altitude or the height, and I need to find it separately. So we're going to say sine of angle C in triangle AHC. So in triangle AHC, sine of angle C is opposite over hypotenuse because it's a right angle triangle. So we can use SOHCAHTOA over there. So opposite side is AH over hypotenuse, which is AC. So sine of angle C would be lowercase h over lowercase b, and if you cross multiply, we can easily find the height of this triangle or the altitude. That's b times sine of c. So if you grab that and substitute for AH in our formula, we end up with a new formula for the area of a triangle. So I know that a few minutes ago, if somebody would ask you what the area of a triangle is, you would say base times height divided by 2. But as of this moment, you have a new formula for the area of a triangle. It is equal to 1/2 times side A times side B times sine of angle C. Okay? So if you have a triangle like this, let's say, and this angle is like 30 degrees, and this side is like 14 centimeters, this side is like 18 centimeters, and we have A, B, C. Okay, if we have a triangle like this, and they ask you to find the area, and it would be hard to find base times height divided by 2. We don't even have the base here. It's hard to find the altitude. So this formula will help you to find the area of this triangle. So we're going to say the area is 1/2 times the base, which is 1/2 A, B, sine of C. I was trying to use base times height divided by 2 formula. I noticed that we just discovered a new formula, so why should we bother? So it becomes 1/2 times A, which is 18, times B, which is 14, and times sine of 30 degrees. Okay, so now all we need is a calculator. So this is going to be 56. Okay, 56. Because these are given in centimeters, the area is measured in square centimeters. So square centimeters, that's the area of this triangle. So we learned a new formula for finding the area of a triangle, and we also did one application question about 2 ships in the middle of the ocean. It was just an example of applying the sine law. It is never enough. We need to practice and do as many problems as we can. Okay, thank you, and keep practicing, please. Thank you.